answer. This decade.
I've got it! I've cracked the code! It's... beep? Boop boop beep? Beep boop? Boop boop? Beep. Beep beep? Boop. Beep beep? Boop boop boop? Beep.
Hydrogen is very accessible and can be produced through plentiful water at certain sites. The hydrogen is extracted when a scientist inserts 2 electrodes into the water in order to create a current that separates the hydrogen from the oxygen. This process is called electrolysis of water.
So we're going to run a red lead to the negative terminal of the battery, a black lead to the positive terminal. And when we do that, you can see bubbles starting to originate in there. I'm going to zoom in so we can see that up close. And that gas is collecting on the left and on the right. Over there. So we're going to let that run until we've collected enough to make a measure.
This method produces no direct emissions of CO2 into the atmosphere and serves as a great substitute for oil. When it comes to using hydrogen, it has efficiency between 45 and 65% in fuel cells, which makes it very suitable and sustainable for electric cars and vehicles.
On the flip side, hydrogen produces a negative net energy yield. This isn't a sought-after quality for hydrogen because any energy resource with a negative net energy yield cannot compete in the open market against other higher net yield energy resources unless it is subsidized by the government. If hydrogen is produced from carbon-containing compounds, there will unfortunately be CO2 emissions that come from the electrolysis of water. Extracting hydrogen would also require money from the government in order to go through with this energy switch. It costs around $3 to produce 1 kilogram of hydrogen through the electrolysis of water. To power one car, it would cost around $160 worth of hydrogen extraction. When multiplied by how many cars and other ways of transportation would need hydrogen in order for this energy switch to be successful, that $160 it took to produce the amount of hydrogen needed to power just one car would very quickly skyrocket.
Some of the drawbacks to using hydrogen energy is 1. Because hydrogen needs to be under high pressure, it would be hard to transport. This would be difficult because of the characteristics of hydrogen. It is flammable, has low density, and is easily dispersed into the air. 2. High costs and negative net energy yield require it to have subsidies to be able to compete in the open market. The technology is expensive, with a small scale because of how recent this form of energy has surfaced. Therefore, research and development as well as the raw materials because of its rarity are both expensive. 3. Producing hydrogen fuel from fossil fuels is not clean. If hydrogen is produced with nuclear or coal methods, there could be severe CO2 emissions into the atmosphere.
So now, you may or may not be asking, where can hydrogen power be used? Hydrogen power can produce electricity to commercial or industrial users. In homes where fuel stacks the size of refrigerators could provide heat, electricity, and hot water. Hydrogen is a worthwhile energy seller, but only if we use low-polluting renewable resources and emit little to no carbon dioxide.